It's my pleasure to be present here amongst you today. And it has been a wonderful day so far with such insightful sessions and engaging audience. And I'm sure this will continue for the last session and a very interesting session too. Myself, Rajkiran, I'm accompanied by my colleague Samrat. We are here to present about digital transformation again using OPC UA. Okay, also we are from OPC Foundation, also known as OPC HUB India. We are also from Siemens. That's because Siemens hosts OPC Foundation in India. So let's start the presentation with the journey of OPC UA itself. This started way back in 1995, although it's not in the slide, but way back in 1995 with an idea of having interoperability on the shop floor. So we started with a very simple step: get systems from 2 different vendors and connect them. And then enhanced it to have mechanism of accessing different type of data, for example, live data, then historical data from the archives, then events and conditions that are asynchronously happening in the system. It then evolved further to become platform independent. And there is a long journey from there. We can see over the years, OPC UA has catered to emerging industry needs, adapted itself to advancements that have happened in the technology. And now, after all this, OPC UA is in cloud, and we are also venturing into digital twin and metaverse. And I am very proud to tell you, OPC UA is preferred communication technology for Industry 4.0. With that in mind, how did this all happen? This was all made possible by one organization, OPC UA Foundation. This is a non-profit organization formed by a bunch of IT and OT companies, again, back in 1995, with a vision to create a secure and reliable communication framework that is vendor neutral, platform independent, and domain agnostic. Not just that, it would also scale from field to cloud. And this is also an international standard recognized by IEC. OPC UA believes in openness, truly openness. So OPC UA spec is freely available for anyone who needs it on the OPC Foundation website. Not just that, OPC UA also provides tools and sample implementation of code in multiple technologies, freely downloadable on GitHub. So I can very confidently say OPC UA provides complete ecosystem needed by all of us for faster adaptation of OPC. Right now, OPC has about 941 members, global members worldwide, and the list of board of directors is here. That we can skip for now. And OPC HUB India, again, OPC HUB India is a regional representation of OPC Foundation. This is being driven by a very passionate team coming together from different companies with the sole intention to promote OPC UA. What foundation is doing, we do that regionally. This is a core OPC UA team in India. While we are talking about OPC UA technology, I would also like to tell you, it's not just an international standard. This is also national standard for several countries, namely Japan, China. So this has ventured into that too. And OPC Foundation not does things for the industry. It also is focused on academia. So OPC UA provides syllabus, resources that are useful for universities, faculty, and students both. And again, this is free. Moving on, let's look at probably repetition. Let's look at our very famous pyramid representation of our factory setup, where at the lowest level we have field devices, moving on to controller, supervisory control, MES system. And we all know this communication is very hierarchical. There is a lot of redundancy and interdependency. This is all quite familiar and has been there for always now. What OPC UA has done is broken this down into an industrial network. anybody on the network can speak to anyone else, and everybody knows and understands each other. That's how it has been now. It is been now. So I would also like to tell you, OPC UA is not a protocol. It's a communication technology that has been devised to scale from field to cloud and even beyond. And the security is inbuilt into OPC UA. OPC UA supports several mechanisms of communication. There is client server, there is PubSub for cloud, and also where determinism is required, there is time-sensitive network too. With that, let's also have a very closer look at OPC UA infrastructure. The entire OPC infrastructure can be broadly, I would like to split it into two parts, two layers. One is communication layer, and another one is information layer. Communication layer essentially deals with all the technologies needed for communication purpose. So like we said before, there is TCP and UDP, and client-server model uses this to exchange information. There is message queuing protocol, which PubSub uses to send across information and receive, and the security is built in. Quick view sentence on security. The session is encrypted, the messages are signed, we support authentication, authorization, auditing. Basically, the security is inbuilt in the framework itself. This is the underlying communication technology on top of which information is based. We call it information layer or information modeling. What it simply means is how the data gets represented and how it gets accessed. So again, we can further split this into three different layers, may not be necessarily one above the other, but supplementing each other. One is core information layer, where this is defined by OPC Foundation itself, where we have mechanism for data access, that is live data, historical data, access from archives, and alarms and conditions. And on top of it, there is companion specification. This is information mapping between different domains. And then beyond this, if for some vendors this is not enough, there is anything more to be done, there is also an option to have vendor-specific information modeling too. Having understood this, maybe information model needs a deeper dive, which my dear friend and colleague would take you into in the next session. Thank you, guys.
So basically, yeah, I was talking about, we talk about, human to human, we speak English so we can understand each other. Now think about the machines communicating to other machines, and that too not from the same make, yeah? That could be different makes of machines, and they want to communicate to each other because they want to extract information from each other and try to make, better use of the information for a better optimization, productivity optimization, or whatever, yeah? Now, the machine needs a language. Machine needs to understand how I could probably communicate with the other machine, right? And there comes this modeling language. You need to structure the way the data is stored so that the other machine can browse and find out what the information is required by the other machine, right? So in this way, if we look at in our future, in this transformation, when this mesh communication network is handled by OPC UA, providing like a scalable machine description, various protocols, security, open source, but the challenge of interoperability comes in the domain-specific harmonization, where in a factory you have different things. It could be some sort of process instrumentation to the discrete instrumentation to other processes which you have to communicate, which are from different domain. And then you have to have interoperability from the cross-domain. As for example, you have your factory data, it has gone to the cloud, but then you have to synchronize your building automation data, you have to synchronize your supply chain management data. So it is cross-domain also has to be harmonized. And all this harmonization requires your data to be handled in a way that which can be understandable by others. Now let us think of a situation that, very simple example. You have, everybody use Windows, and we have our, all our files and file folders are structured in a way. Now suppose you want to search a particular file from there, and you don't know in which form and where it has been stored. So obviously, it takes a huge amount of time for you to really find out that information. Actually, the model actually helps you to probably structure your mod, probably the folder structure, you know, in your files. You can correlate over there. And with OPC UA, what we call such models called companion standards. We call it companion standards because there could be n number of machine, n number of possibilities, like it can be oil and gas, domain. It could be, cloud controller field device. It could be energy field. It could be building automation. All have their specific information, which has to be structured in a way which can be understood by the other domains. But every of such domain have their specifics, which has to be understood and standardized. And that's where comes the companion specs, which is developed by already, there are almost 105 groups of domain experts who is developing the global standards for such things, and we call OPC companion specs. And this is the largest ecosystem for information models in the automation world. That's what is they are producing. You can always go to our OPC Foundation website to get more information about different companion standards, what is available. As I told, let us talk about a use case now. I mean, to give you some sort of an example how it might work. You can think about a machinery, or let us take the mechanical engineering field, yeah? And there is a standard or a base, companion specs called OPC UA for machinery. Any type of machinery data can be organized by using such a standard of modeling. But this particular OPC UA for machinery can be then derived to put other different machine, like a cutting machine, laser machine, or machine tools, pumps, or any wood cutting machine, or whatever. Yeah. So every of such machine has a specifics, and that specifics also has to be structured in a way which the other the parallel machines can understand when they are talking to each other. But then why they can talk to each other? Because they are derived from a basic base. I would say companion specs, and that is called the OPC UA for machinery, right? So with this common structure, all these machines can talk to each other when they have implemented such a model. Now I will go very small use cases to tell how this information model is helping to make your digital transformation a reality. Let us talk about different use cases like machine identification, component identification, machinery state, and process values. I will start with machine identification. Now, in a factory, there could be different types of machine. There could be a CNC machine, there could be a bottling plant, there could be a robotic arm, and everybody has their information which they want to share or they can share, which others can take. But the main problem comes, how do I find which is this machine? Can the machine tell me, if I ask a machine, or if another machine asks the machine, who are you? Then can it tell in a way that this is my type, I have been manufactured by this company, as for example. So OPC UA for machinery provides you the structure. This is the structure, how this information has to be placed. So there are some mandatory fields which has to be followed, and other things can be derived also. So this defined structure, which is globally accepted, gives you the possibility that if you are producing a machine and if you want to expose your data, then you can probably follow such a structure so that any other machinery can query or browse your data and get the information what you want to share, right? It is when it comes to component identification, every machinery could have multiple components inside it, or it could be having another machine as a component. So that is also under this under this information structure. You can also have your component information structured in a way which can be browsed from the machine and go to each and every components and get every component's data also, right? Now, machinery state. Now, it's a common thing. I mean, you have a factory where there are different machines, and these machines could be running at different state, right? Something is working, something is running, executing, production, die run. Now, if I give it to the machine producer or OEM to talk about what all states his or her machine can produce, they can probably tell you different language. Okay, I have a machine like this has 5 states, this is something like that. But then we need a standard way of understanding what is the machine state at certain point of time. So here, what OPC component specs for machinery comes up with 4 standard states, just 4 standard states, and this actually will tell all about any machinery which can be organized in this type of data. And such a state model can be represented like this. And you can see here, like, you can also elaborate one of the states as, for example, executing states, ready to run, manual run, controlled run. So what it means that once these 4 states are given, you can also probably, derive your particular machinery states, which is very machine specific, under those particular, structure. So it's a possibility to expand your machinery state depending on your machine specifications. Now, let us talk about, another thing is about machinery state. Now, once such a state is understood, then it is easy to define some dashboards or extend some dashboards to understand what are my machine doing at certain point of time. Sorry, my time is over, but I will take a little bit more time. Now, another thing is component view. If your machine is out of service, how do I know why it is out of service? Then, because I have already structured my model, I can go to the machine and then go to its components and find out which component has a problem. And this is automatically given by the structure, because you have already modeled your whole machinery and its component in a way which is browsable, and you can easily find out where is your problem in a machine. Another very important thing is KPI calculations. Now, all this information is out of service, not executing is given. You can log like how many hours this state was there and try to find out the KPI availability of a particular machine very easily, right? So, just by structuring your data, you can achieve so many things. Process value, it's also simple. Suppose you have different machines, they can probably give you different way to represent their data. Like if it is a temperature, everybody can have a different way to tell what is their temperature. So it's a blade or nozzle or all. But when you have a standard way to do, everybody talks, my temperature is this. So this is all about some small use cases to show you why modeling your information is so very important to transform this data, and how modeling could help our future need of machine talking to other machines. Yeah. A little bit about, now all these things, we need to talk a little bit more about advertising our OPC also. So I will talk about the different type of membership, what the OPC provides. OPC have corporate members, end user member, non-voting members, and logo members. Corporate member means you have access to everything, and you can probably contribute to the working group. You can, if you want to work on a new company specs, you want to work on, you can contribute, or you can be part of a working group providing such things. If you are an end user member, that means you have already products, and your product is, have OPC components and all, and you want to expand with your capability by taking the new offerings from OPC. You can probably be the end user and try to get connected to the experts group and collaborate over there. Non-voting members are mostly government and universities who wants to understand what is the standard coming up and being part of the standardization body. Logo members are members who can, suppose you have a product and you want to get the OPC logo with it, you have to just contact the OPC Foundation, and then You can provide your marketing informations, and OPC can go through it and give you an OPC logo. So with that, you can market your product as an OPC compliant product. By the way, logo member is free, as was Rajkiran telling, and to become a member, you just have to go to visit our website. And yeah, that's all I wanted to talk about, because I had a small video, but yeah, my time is over. Yeah, just a 1-minute video. Yeah.